some code grammar, but we don't need that. I shall close this. Do we need that? That's the Python coding. I might actually, maybe I'll actually work into this. Don't like the fact that keeps on not being there. And that's the book. There we go. Go get it. That's very cheap. I guess there's loads of books on programming. You should get this one because it's the best. Zetra notes, the Euler methods. Yeah, interesting stuff. And my LinkedIn profile with some chats. Probably won't need that either. So yeah, let's go and start with basically this barred question here, which is, so I'm looking through my code. I'll go back to the original bit. This is code written in, I'm not even sure if can you see the date of the code? I know that unlike one of the editors that I was using, VS Code, it actually showed when the code was made. I guess I could reveal in File Explorer. Actually, I wouldn't be able to see that because that's just going to be the last Git. So 2025, but this was written ages and ages ago. Maybe if I looked at the GitHub, it would it'd be closer. They'd get the date. But anyway, I wrote these ages ago and I've forgotten. Well, I know what a static method is. I also know there's like a whole bunch of other types of methods that have these method decorators. I should call them method decorators or something. I don't know. Someone in the comments tell me what we call them. These decorators for methods, which are functions inside of a class. So I know what this one is. This one's probably, I will call it the easiest of the methods, which is the static method, which is basically, if you just want a function in a class, you don't want it to change its attributes in any way or do anything. It's got nothing to do. It's just it happens to be a class that's really only got use inside the. So it's a function that's really only got use inside the class. That's what the static method is for. And I wonder actually if I've written that anywhere here. Do I have a section on classes? Scope. Enclosing scope, local scope, global, inner, outer. Okay, interesting stuff. Problem with this is as it gets longer, it gets harder to, because it's this pip thing. Right, geez, back in the day. Decorators, here we go. So I have that. Again, this was a long time ago, but here's an example use, I guess, of the static method. In Python, the @static method decorator is used to define a static method, which is a method that is bound to a class rather than an instance of a class. Static methods are not associated with a specific object, and they do not have access to the instance variables of a class. It can't do anything other than it's just a method. It just belongs in there. And then you've got this class method, but I've kind of like, I've even given a use. There's no use case here. So I'm going to look at the use cases, and then finally there's property, which again like is used for getters and setters, and I've never really massively done that, and it's got something to do with the attributes and things of the class itself. So anyway, I'm going to ask for examples, I guess. I don't know if I'm going to build on this because this is just like the framework, but we shall go to, I've done this in Gemini, or Google Bard, I guess. I don't know if do you call it Bard or Gemini? Well, I've called it Bard. It's Gemini here. And the question is this: list all the decorators that are used in classes. So kind of like that's where we're going to go. Let me just close this one as well. And it actually lists the top 3. So whoopee. At least that bit's like makes sense. You've got the static method. You've got the class method. So decorate used to define a class method within a class. It takes the class itself, conventionally named CLS, as its first argument. It can access, modify. It can access and modify the class state, and it's kind of like, what does that mean to access and modify the class state, but not the instance state, which is often used as an alternative constructor or factory method. And finally, the property thing, the property decorator, which is used to define a getter, allowing a method to be accessed as an attribute without the need for parentheses. So let's just have a look at these. So I'm going to do short. I'm typing in here at the bottom. So zoom in a bit. Kind of just down here, this little piece. A short example of each of the above methods in isolation. And I don't want to see like one. I don't want to see like a class with a static method. I just want to see a static method on its own, then a class method on its own, and so forth. Or I could actually put of a CLS. Let's see what it does. You are asking for the example, a short example of the at-class method that uses a standard argument CLS. A class method is bound to the class and receives the class itself as its first argument, conventionally called class. So let's have a look. For example, I've seen this example before, I think maybe. This is probably out of the docs pretty much, but let's go for it. For example, showing a class point and a class from string that acts as an alternative way to create a point object from a formatted string. Okay, so let's see this in action. We define this class called point. We've got the init as usual, so self.x equals x, self.y equals y, so they're the x and y coordinates. Instance method, so here if you just want to display, I guess you're just going to get the f string, because you're going to get the string back with point self.x and self.y. Okay, so you could do something like point.display and that would give you that back, which I think will be, here we go, not point.display but p1.display. So we would, this is a standard instantiation down at the bottom, so it's giving us a usage example. We would do points, we'd pass in, this is x gets the value of y, gets the value of 5, y gets the value of 10, and then we could do p.display and it will give us back this, because that is the result of this f string up here. And same thing, so here you go, you've got point 2 over here, and I guess this is going to be the difference between them. So it takes this string, and I guess it's going to deconstruct the string. So it can take this 100, 200. It's going to deconstruct it into 2 pieces using this split method here on the comma, which acts over here. So it's going to set x string. So x string is going to get kind of like the first piece of this, then we're going to have a split, and the y string is going to get the next piece of this, and it was split by this comma, which is this comma over here. So it's kind of like deconstructed anyway. It's going to return the class instant. Right. My question with this, well, I don't know, could I do this in a different way, I guess, and like because I tend to, I've never used at class really. I don't think I've used it. So I wonder where I would put this, because it's not going to go in my math module, that's for sure. Brilliant.org, blockchain, VS Code. It probably doesn't belong in any of these, to be fair. Code testing, Node, Python. Doesn't belong here. I was going to sort of like do like a test example, but these are all like functions. So let me just see if I've got somewhere test. That's now my Google Drive, and I'm kind of like not using them anymore. So general tests. Okay. So let's open this up. And I wonder if I've done like test of a class, because I could NumPy, pandas, plotly, recursive, this, that. Test import, okay. I could make a little folder called decorators, because the thing about this is some of my stuff has got quite long. So test folder, but I don't want a million folders either. Test the class method. Test class methods. There we go. So let's see what examples in here. My class, description of class. The inits, again, we've got A, which is an integer, and B, which is an integer, or a none, and we set it as none. I wonder why I've done that. Maybe as an example. We initialize a class. A is the first argument, B is the second argument. Okay. So we've got an add method, a sub method, a multiply method. So this is one I did a video ages and ages ago. I probably won't even link it because it's so far away. Oh look, the linter doesn't like this now. Comparison to none should be conned if it is not none. So the rough linter doesn't like my code from 5 or 6 years ago anyway. But I don't actually use CLS anywhere in here, funnily enough. Test class methods. So far at least I haven't. Or maybe I was just talking about these bits. So because I haven't used the CLS anywhere. I was talking about all of the double underscore methods, the dunder methods that go in classes. So even that, yeah, so that's not there. I should call them decorators then. Test decorators. Here we go. Let's have a look at that one. Even that's not going to be the case, because this is going to be making decorators, I think. So I'm probably going to decorate this function somehow. Yeah, I am. Doesn't like that because we've got imports. It's going to, maybe the imports need to be at the top. Not at, yeah, module import level, not at top of file. Naughty, naughty. Time and math, importing libraries. Right. Let's just move that anyway, just for the sake of it. X and actually Z. Paste it over here. Here we go. Not going to complain that now. So if I was to go here and Why is it not recognising that there needs to be a commit? Oh, it does now. No, it doesn't. Oh, maybe because I have to hit the save button. Yeah, that's right. Control S. Move decorators to the top. Add missing library imports and remove duplicates. No, that's not a good comment. Move imports. Tab. Save all commits. Sync changes. Yeah. So yeah, let's go and have a look then in that case, because there is nothing done as far as I can see here as the class decorators. So we go back and maybe I'll put test class method, but that is test. I don't know if I'm allowed to put the at sign in here. Let's just do that. At CLS, or I'll do this CLS underscore method dot py, so it goes next to the class method. So let's see, that looks a little bit better. And then we take this and paste this here. Code looks acceptable, and we run our code, and we should get this, you know, this piece and that piece of the outputs down in a bit below. So let's hit F5 to run that, the Python debugger and the Python file, and just run and debug and the Python debugger, and hit yes node. Oh, I don't want to start any other instances. Okay, cancel that. That's pretty much it. So yeah, down at the bottom we get points 5 and 10 and points 100, 200. So I just run that again. Yep. So that's all fine down at the bottom. This thing here is a class method. I guess the question is I don't know if it's a great example. Or is it a great example? I don't like that as an example. I'm not happy with this example. It's almost like if I wanted to get X and Y inside of this thing, like why would I ever, like I'd want you for like force users to pass a string, but it's almost like, let's say they did pass a string, I could still just read this string in here, like if that was necessary, like, oh, I want a string. But maybe it's a case of let me just put like this is, I'm just wondering if they all agree with me, say yeah, it's not a good example. I'll give you another example. This is not a good example since the user could achieve the same well, maybe it will defend itself. In Python, there should only be one way. In the Zen of Python, I don't know if I find that out somewhere here. I wonder if did he even have a Zen of Python in here? Home. I think actually the Zen of Python is outdated and kind of, yeah, it's probably outdated, but the Zen of Python, you know, there's like this statement about what things should be. Somewhere down here, I don't pick faults in it, but Beautiful is better than ugly is quite a nice one. Explicit is better than implicit. Love that one too. Simple is better than complex. Agreed. Complex is better than complicated. Yes, correct. Flat is better than nested. I can live with that. I've lived with that. I quite like it. Never nesting. Sparse is better than dense. Okay. Kind of like yes and no there. Yeah. So like agree. Readability counts. Absolutely. That's quite a good one. Special cases aren't special enough to break the rules. Probably agree. Although practicality beats purity. Okay. So like, you know, this contradicts the one above it. Errors should never pass silently. That's quite a nice one. It means like you really understand your code unless explicitly silenced. So yeah, this doesn't contradict. This one complements. In the face of ambiguity, refuse temptation to guess. Okay, yeah, that's a good one. Right, this is the one here. There should be one, and preferably only one, obvious way to do it. And I think this rule is possibly breached here. I'm going to see. Although that way may not be obvious at first, unless you're Dutch. Yeah. Yeah, anyway, so let's go back to the actual, because yeah, we're effectively like breaching this. There should be only one, and probably only one, although that way may not be obvious at first. So maybe there is one, and like, you know, this is the obvious way. So this is not a good example since the user could achieve the same in other ways. That's a fair point. While the previous example showed how a class method works, it didn't fully illustrate why you would prefer, and this is the thing, like, I don't get, at least from that example, why I would prefer it over other ways. So let me put a little hello in the comments. So so I typed something in the comments bit, wherever the comments show up. So yeah, let's have a look. A compelling case, and that's what I'm looking for. A compelling case for a class method is where you're dealing with inheritance. Okay, so now I'm hoping that this gives me an example where, like, I must use a class. It's kind of like the obvious best thing. So a compelling case of using class methods when you're dealing with inheritance and want the alternative constructor to correctly return the instance of the subclass and not the beta classes, right? So that's kind of like, whoo, blur. Here is an improved example of class in hierarchy. So let's see what it does here. Improved example, class method of inheritance. In this scenario, we have a base class log. So I'm going to go back to this piece before I do that, and maybe we'll put sort of like here. And here, example number 1. I don't need to put a number, I guess. There we go. I love a bit of auto. Sometimes I like the autocomplete, sometimes I don't. But here's a nice trick, which is if it starts annoying you, you can snooze it out or switch it off. So it's quite a nice little feature from Copilot. I see that my Copilot doesn't actually use a lot of stuff, so yeah, I haven't used much of my completions. So sometime Copilot will start charging, and then yeah, our ignorance level will go up. I don't know if it ever will actually, or at least I'll use a different AI at that point. So let's go back to the example that we were given, so we don't diverge too much. Guilty of diverging. Improve. Okay. In this scenario, we have base classes log And so we have a base class log, so they're referring to this class here, that's the base class, and a subclass called error log, okay, error log, that inherits from log. So just notice that, I guess, this log is in here, so inherits from log, so don't need that. We want a generic constructor that creates an instance from a dictionary. Okay. And we want that constructor to work correctly for the subclass. Ah, okay, right. I think I'm getting it. So this is the generic class. You initialize it. It gets a message and a timestamp. Okay. Right. And then display self. Okay, so it gets a message, and then it will just, yeah, it's got the display, it's display method, so it'll display the self and timestamp. Again, like, I wouldn't necessarily use this display because there's like a double, there's a dunder method for that anyway. But let's go along with it. And then it's got this class method from dict, right? An alternative constructor that takes a dictionary class, that takes a dictionary, and then class ensures the correct type is returned. So it takes its dictionary and it returns back class message data, datetime. Okay. So the first argument is going to be the message from the dictionary. So it's going to be message and right. The crucial part, class calls the init, the double underscore init of the actual class it was called on, either log or error log on the actual class. Okay, fine. So, okay, fine. So if it was called here, it would take data which would be the init here. It will take the message. I guess it will take, okay, fine. It's going to message, the message, and then the timestamp. Right, so here's the dictionary, this data dictionary, so it's taking in data. I wonder where that is. Okay. Right, it's taking in data and spitting that back out. So calling the class method on the base class is okay. So let's like get an example. So we've got this log, which is this first class, and then and you've got this data. So we want to log this data. Okay, so log entry is log dot from dict, and that is the class method here. And then it's going to print us this here because it's going to get this class method. It's got this print. Okay. I'm going to print the F. Right, it's going to print the type of log entry, and the type of log entry, I guess, is doesn't actually show us here. And then log entry don't display, but the type is probably going to be that class then in that case. Okay, and then calling the exact same class method on the same class, so it's going to print error entry, so a different one. I guess they're different. They're going to be different types, type 2. So let's take that example, and we go back here, and example 2. Look at that. I don't know if this is going to be. I wonder if it's going to change the. It just so knows everything. And before we do that, I'm just going to do print, generic print statement. Look at this. It's just so clever. Well, okay, do I want to do more of them? Just printed 20 dashes basically to separate them. Okay, we can just run this. So the top bit will be the first piece. Right. I'm just wondering why. What I'm actually wondering why is I've got like that there and that up there. Interesting. Where did these dashes come from? I didn't. Is there more dashes there? Oh, here we go. Right. Okay. Fair enough. There we go. Wonder if that string will concatenated. It's an ugly concatenated string, but that might work. Look a bit cleaner. There we go. So we get a double line and then example number 2. I wonder if it says example number 2 anywhere here. That won't do. So let's just run that. Now we can see example number 2. That's all. Ooh, don't like that. There we go. Let's just run that one more time. So now we just separated the 2 examples. That's all. Maybe I shouldn't have even put example. Now I need to probably put example number 1 here. There we go. So we've completely kind of like, I don't know, sort of like down at the bottom now. We've got example 1, which is this point that had a use case, but now we're focusing on this, which is example number 2, which is, so we've got object type, and I think this is the key, or at least one of the keys, is, let's just kind of like do that, scroll down a bit, noticing it's got like this highlighter thing, but this piece here, which is main.log, and this piece here, which is the error log, they're the 2 different types. And in here it's printed out this log and it's got like disk full. So just wondering where that. Okay, fine. So it's got this message disk full, which is here, and that's gone into the log, which is here. Okay, so that's made its way. So I mean, this is kind of like the example. So you've got the log and the disk full, and so that's the method that exists in the class, and is using the class method. But here now, you've got this level equals critical. You've got this error in the subclass, and it's able to pass that message into here. So you've got this critical error, I guess, because you've got this self.level, so that's critical. And yeah, now I mean, I don't know if it's useful or not useful. My code never gets to that sort of level, but the code doesn't really work in the firm. The devs might end up with this when they write way like more complete code than code that I would necessarily write. But this becomes necessary at a certain point. So let's read the necessary piece of it again, which is, so like kind of like why is your question. Let's get rid of all of that. Why is this a better example? Okay. Polymorphism. When you call error log dot from dict data, the class argument inside the method is automatically bound to the error log class. So when you call error log, which is, I don't even see that there. When you call it from underscore dict, so when you call this from dict, it's automatically attached to whichever class it was called from. Okay, fine. So like it's sort of like assigned specifically to this class. So I know that I've called it from, I guess that's the difference. It's class method now. I know that if I've called it specifically from the log method, I'm going to get, my log behavior on this thing. And I never had to, like the user never had to do any work. And if it's inherited from here, but it's been called from here, like the user automatically gets this, and they didn't have to do any work between the two. So like you didn't have to do anything more to achieve this than define this class method one time, basically. So that's kind of like that's an example of its use case. Let's see if there's any other sort of like commentary on that. Get rid of the dots over there. Put them back. Just delete them. I won't be coming back to that. So yeah, let's just go back to this. Correct instantiation. The line return class data message class time ensures that the method returns an instance of error log which calls the subclass init, not an instance of the base class log. I'm going to just do one thing as a test. Even before I read the next bit, which is basically if I stick something in the init like print, open that, or maybe it will, I don't know what will come out of that. Like the init's been called, so like a log's been created, it gets created twice. Do we get 2 times? Like I guess, like what goes in there? I believe That'll be an interesting one. Message timestamp. I'm presuming that two different messages get called. So let's just run that F9, not F9, or breakpoint in F5 to run it. And we're looking for this log created, and it's got here log created full disk full and log created disk full. So calling that on its own is, that's interesting. Because that's still using the self, I guess. So that's why, and I guess that's going to be the difference. Like how did we, like, so this is basically would be unsuccessful because this is working on the instance each time, so it's not doing the differentiating thing. Whereas when you've got the class method, it's almost like run it again. So I guess that's its use case. I don't know, like for a full-on coder you'd find it useful, but for someone doing much lighter work maybe you wouldn't find it useful. Like if you're building a bigger project, the class method is going to come into play, and if you're building like smaller projects you may never use the class method basically. But let's go back to that last piece and see what it said there. If from dict were a static method or a regular function, it would have to explicitly hard code return log. Okay, so you couldn't achieve this like with a static method, but I think that was obvious, which would break the called from error log. The class argument is essential for this dynamic behavior. So here's an example where it's important, or at least asserted to be essential. So okay, that's good. And then provide, let's move on, an example of the at property at property class decorator. I call it a class decorator, I guess. It's just the at property decorator, not the at property class decorator in a Python class. So the at property decorator in a Python class. The at property decorator allows you to. I mean, I'm kind of like, this one's a bit. I think it's a bit more intuitive, which is. I mean, I don't use it, but I can see where it would be used. It's kind of like where you want to isolate the class in its own. So you've got these getters and setters, and that means that you can't inadvertently, at least this is a use case as far as I understand it, you can't inadvertently like set the temperature without using the setter like method that's over here. So you've got at Fahrenheit.setter, and you've got a deleter, so you can't accidentally delete it. That's the case, is to kind of like make it sort of like almost very explicit. So let's read this anyway. The at property decorator allows you to define methods that can be accessed like attributes without parentheses, and also enables the creation of corresponding setter and deleter methods for controlled attributes manipulation. So this example class temperature, where the temperature is stored in Celsius, but we've provided property methods to get and set the value using Fahrenheit as well. So yeah, okay, so this uses Celsius, but maybe I want to convert. So maybe I want to get the temperature in Fahrenheit, do a conversion, and then kind of like set that as a Celsius value. And here's a little formula for doing so, which is 9/5 of the Celsius plus 32. So that's kind of like, you know, what this piece is. So it gets the self and the underscore Celsius. and it gives you back your Fahrenheit basically when you do that. And you can also set it, so that's the way to set it. I wonder why here it's called @Fahrenheit.setter in particular. Because you've got this Fahrenheit. Yeah, and then you're going to basically set the value of it. Okay, fine. And you've got this Fahrenheit.deleter. So, and then it gives you these use case examples of what you can do. So I think that's more intuitive. Like, they've all got their cases. I'm not even necessarily sure. I mean, I haven't really used setters and getters because, again, I think like the code that I tend to write is sort of like more simplistic, and I can get away with it. But when you've got like much larger code bases, that might become important, because then you can, at least the developer can force other developers to follow correct patterns. So my patternage may be either not necessary in like the small code that I write, or like underdeveloped compared to like when you've got like a larger block of code. This is Python's way of, I could say, almost like Python's way of matching like the more strongly typed languages. This gives you that structure that you need, and I think that's going to be it pretty much. So yeah, thanks to Gemini for answering the questions and to like giving some good clarity there. And yeah, thumbs up and like the Zen of Python. Yes, if you do like that, fantastic. And follow and subscribe. Go get the book. Yeah, follow, subscribe, like. By all means, put your comments in where, like, I don't know, my language and nomenclature wasn't good enough. Yeah, put your comments in if you like think that basically the code isn't good enough, or like it could be improved, or like this example here from Gemini wasn't the full example, and you've got a counter case or a question that arises from it. That would be yeah, useful to hear. And that's the end of the stream.